take a look at page 2. Here we're looking to determine whether the graph has a Euler path or Euler path, an Euler circuit, or neither. Remember, with a path, we would have two odd degrees, and with a circuit, we would have all even. Okay, so all even with the circuit, two odd degrees with the other, and then if we have any other combination, it's going to be neither. So let's go ahead and take a look. I'm going to just write the degrees right on the graph, and then from there, we'll go ahead and make a judgment. And if I have to erase some of that to get it out of the way, I can. All right, so let's look at A. A has 3, E has 3, C has 3. I'm done. Remember, I have to have exactly 2 or none. I already have 3 here, so this is going to be a neither. I don't even have to go through anything else. All right, let's look at the next one. This one, I have 2, 1, 2, 3, 4, 4, 1, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. So I have all evens. That means I have an Euler circuit. So this is going to be a circuit. And now what it wants me to do is go ahead and complete the circuit. Now remember, when we have an Euler circuit, we can start from anywhere, but we have to end at that same spot. So it doesn't matter where you pick, right? So let's choose, I don't know, we'll choose D as our starting point. And so I'll go D to E. So let me go ahead and start writing this as we go. So D to E, and then from E to B. So E to B. And then let's see here. I can go, let's go to C. Let's do that. So D to E to B to C. Let's go up to A. So A is on there, and then I can go to B. And then I can pass through, remember, right? So I can pass through and go to from B to D. And then I can keep going to F. And then I can keep going to C. Again, yours may not look exactly like this, which is fine. There are so many paths, and then finally back to D. Okay, so your key here is understanding that it starts and it ends at the same location. So since we started at D, it has to end at D. And again, your path may look slightly different. That's fine. Absolutely fine. You're going to find a way to get it done. All right, let's look at number 11. Again, I'm going to go ahead and list my degrees. So that's 2, that's 3, that's 3, that's 4, and that's 2. What do we have here? Yep, we got a path. We have an Euler path. Now, A is a 3 and C is a 3. So those are my 2 that I have to start with one of them and end on the other. I don't care what you start with. I'm just going to start with, I'll start with C. Okay, so I'll go from C to D. So C to D. And notice I'm not numbering them. It's fine to number them if that's what you want to do. I don't need to because we're writing it down as we go. So C to D to E. And then we're going to go from E to A, which is fine because we got to go there a couple times. And then we'll take A to B. So B. And let's go down again to E. And then go from E to C. And then we'll head from C up to A, right? The big thing with a path is that we start on one of them. So in this case, I started with C and then I ended on A. So we're in good shape. We started on C, ended on A. So always, always, always start with one of your odds and then end with one of your odds. All right. Now let's go ahead and take a look at a graph that models the layout of the city. I have the North Bank, I have these two islands, and then I have this South Bank. So I'm going to go ahead and do a North Bank dot, and then I have the two islands, and then I have the South Bank. So I'm going to call this SB for South Bank, NB for North Bank. I'll call this island B, and I'll call this island A. You can have different, if you want to call it A, B, C, D, that's fine, right? As long as we understand where you're going. All right, so I'm on the North Bank, and I know that I have two bridges that go to B. So I'm going to go ahead and draw two bridges that go to B. And then also from the North Bank, I have a bridge that goes to A. And then that A also has a bridge that goes to the South Bank. And then the B island also has a bridge that goes to South Bank. So that is a representation. We got all the bridges, right? That's a representation of that map. Use your graph to determine if the city residents would be able to walk across all of the bridges without crossing the same bridge twice. Explain your answer. Okay, so remember that an Euler's path or an Euler's circuit has to cover all of the edges in a path. So I'm looking to see if I have a path or a circuit. If I look at the powers of each of my points, and B has 3, A has 2, B has 3, and my South Bank has 2. All right. Yes, we can do this. And why? Because we have a path, right? We have two odd numbers, the North Bank and that island B. If such a walk is possible, show the path on your graph. Then trace this route on the city map in a manner that's clear to the city residents. Okay, so if we're doing a path, let's think logically about this. I'm going to start on one of the main banks. I'm not really going to start on an island, but you could, I guess. So I'm going to go, so I'm going to hit North Bank to B, and then I'm going to go back up North Bank. And then I'm going to head over to A. I'm going to head down to South Bank. And then I'm going to head over to B. All right. Remember, you have to start at one of them and end at the other. So we ended at B, which is good. That's what we want. And then now it says to do it, let's see here. Trace this route on the city map in a manner that is clear to the city residents. Okay. So if you're a city resident, let's go ahead and set up shop, and we're going to go on to the island. Then we're going to go back over across the bridge to go to the North Bank. Then we're going to go across the bridge to A, and then we're going to go to South Bank. We're going to take this road here, and then we're going to go back up to the island B. So that looks like a pretty easy path for a tourist to take. All right. C map. Use your graph to determine if there is a path that crosses each bridge exactly once and begins and ends on the same island. Explain your answer. Okay, begins and ends on the same island. We already checked out this thing, and we know that this is a path, not a circuit. A circuit, you could have it start and end on the same island. With a path, you can't, because you have to start on one of the odds and end on the other odds. So, no. It is an Euler's path and not a circuit. So it cannot start and on the same island. Okay, so there's our answer for that, and that's page 2.